how do you do it algebraically? The first thing you do is you rewrite in terms of y and x. You know, back when you didn't have to be so sophisticated. So we're going to write this in terms of y and x. So I'm going to change that f of x into what? A y. Y is equal to 2x plus 5. Like all things that are supposed to impress people, you go back to the basics, all right? So you change y and x, or f of x, into y. The second thing you do is you switch the x and the y. So x is equal to 2y plus 5. Okay? So the first thing you do is you change f of x into what? Into y. And then you switch what? X and y. And then the third thing, solve for what? Y. Solve for y. So x minus 5 is equal to 2y divided by 2. And x minus 5 over 2 is equal to, not y, but y what? Y inverse. And that's what they're asking for. Y inverse, or f inverse of x, which is y inverse. So write that down because I will ask you to do that on a test. Okay? So make sure you know how to find the inverse function. That's how you find it.
That negative 1 right there of y.
That means y inverse.
That means y.
Just which see that f of negative 1x? That's the same thing. So let's see.
How did you get that?
Huh?
Where did the negative 1 come from? Just moving it over to the other side?
Well, the whole thing, when you switch it right here, basically, when you switch these two right here, this becomes y inverse. There we go. Okay? When you switch these two, that's when y becomes what? Y inverse. So that's how you get the y inverse at the end. You've never done that before. You've never taken x and y and exchanged them. You never have done that before. This is the first time you've seen this in this class. So when you do it, the x, technically the x is x inverse, but we don't do that. We're concerned with y inverse because that's what you're wanting, and that's what they're going to do. Okay, so y is equal to 2x plus 5. Then what? Switch the what? Switch the x and the y. Thank you. Interchange the x and the y. There we go. X is equal to 2y plus 5. And then solve for what? Solve for y. And then when you solve for y, you basically have y inverse. They don't call it y inverse, but that's what it is.
They call it something fancy.
There. Replace y with what? F of negative 1. So what is that? Well, I want you to take your calculators right now. Get out your calculators. And I want you to graph 2x plus 5. And then I want you to turn around and graph x minus 5 over 2. While you're doing that, I'm going to get out my handy-dandy calculator, which works half the time. Somebody write those down. F of x is equal to 2x plus 5. And y to the negative 1 is equal to x minus 5 over 2, because I'm not going to remember it. And I'm going to escape, pull up my handy-dandy calculator. Just fancy schmancy. Same difference between a laptop you bought a year ago and a laptop you bought yesterday. All right. Graph. What's the first one again?
2x plus 5.
2x plus 5. And the second one, I'm going to change to a dash line. So I go over to the line and I hit enter 2 or 3 times until I get the dash. There we go. and and somebody give me that one. I'm gonna put parentheses. What was it? X what?
X
minus
minus
5.
5
X
over 2.
minus 5, close parentheses, divided by 2. And graph. There's your first function, and there's your second function. Now basically what they are, they're opposites of each other. Okay? They're symmetrical, and you can see that the mirror is technically y is equal to x. In other words, it flips. Okay? That's the difference. Now, when you see this, I'm going to show you in a second what it looks like really, is take our handy dandy. Let's see if hopefully they'll give us a better example of x to the second power or x to the third power. I hope they do. Probably not. There we go. All right, I want you to do this one. X squared plus 2. And then at the end, I want you to graph both functions. So go ahead and do the inverse of this function. It's my vodka. Leave me alone.
Chocolate vodka.
Yep.
My favorite.
My daughter, she's a waitress at the Galley. And for those of you who don't know, the Galley is a restaurant in Anderson. Two kinds of people go to the Galley: the people that want to have money, and the people that do have money. Mm-hmm. All right. And I tell my daughter, I said, the ones that treat you the best are the ones that really have money. The ones that treat you the worst are the ones that don't have money but want money. Anyway, she's found that out. She said, "Daddy, you're right." I said, "Told you."
Usually.
And yeah, daddies are stupid, aren't they?
Yeah.
We're stupid until y'all get to how old? 25, 30, somewhere around there. And then y'all start to figure out that we actually know what we're talking about. Anyway, she said, this woman came in yesterday at 4 o'clock. It's right when they opened, or whenever day, I don't know what day it was. And she ordered 3 in a row, vodkas on ice. Vodka on the rocks.
Oh boy.
I said, Lauren, give her the benefit of the doubt. There's only 2 directions there. one, she's alcoholic, or 2, and I hope it's the second one, she's had a bad day. She drank 3 more after.
Alcoholic. And that wasn't her first 3 of the day.
Oh no, it wasn't. Because if anybody has had vodka before, it's like paint thinner. Okay, it's the worst. In my opinion, it's the worst alcohol of them all because the taste is so strong, and I can't drink it. I kid about it, but I can't drink it.
Isn't it big?
I mean, I can drink Everclear, but Everclear doesn't hold it. To me, the taste of Everclear is a whole lot better than the taste of. I mean, vodka is just strips paint off, and if you drink 6. And I said, was this a big woman? She said, nope. It's very, very thin. I said, the tables are starting to turn toward the former versus the latter. And I cannot imagine. Can you imagine drinking 6 vodka on the rocks? I can't. I would be buzzing. I mean, and I'm pretty good sized fella. I mean, I would be buzzing. I wouldn't be drunk or anything. I'd be buzzing, but she said she got up and walked right out. I was like,
She definitely.
And she drove home.
yes, it said she was
By herself.
She was what is it when you're cognitive livid? She was very coherent, paid her, did her thing, didn't have any problems, gave a tip, walked right out. Whew. I guarantee you she probably had another bottle at home.
Yeah.
I don't know. It's
Unless she had her belly
made out of rice or something instead of potatoes or something like that.
Well, that's not vodka then.
But it is vodka. It's rated #1 vodka. It's like, it's good stuff.
I've never tried. I've never been able to drink that stuff. Well, I don't have an addictive personality, so I'm addicted to movies, I guess, but I'm not addicted to like bad things, which I'm very, very thankful for. because some people do have problems and stuff like that. And I'm just glad I don't have one of those personalities. I hope my son and my daughter don't either. My dad, my mother and father didn't. So I don't know if it's hereditary or emotional or what is it?
Yeah.
Is it
The jury's out.
psychological? Huh?
The jury's out on that one.
Yeah.
Might it all come from the parents or just-
But I think my heritage. Now, there's a side of my grandmothers. They drank like fish, and they were known in Anderson County for being drunks. But that was like way back, like dang old Reconstruction, dang old long time ago. But my father's side, they were devout, anti people that drink alcohol. So I think there's something to that genetic thing. I really do.
I mean,
Something. I didn't say. Now,
Percentages are
is there
very
times in your life to where you can get addicted? Yes. I think, that's why you need to take all the psychology classes you
yeah,
can
it's
take.
that whole nature versus nurture.
Yeah.
It'll never be solved.
And you get beat down, as Rocky says, you get beat down and beat down and beat down. Some people, instead of getting back up, some people, revert to other methods.
Some people like that.
And then you got that side. Some people just like to go out and throw one and then feel bad the next day, And some people bring it in their work, like I do. All right. I just told y'all I can't drink vodka, so that's not bourbon and chocolate. I don't think. I don't even want to kid about that. That don't even do it. Oh, that makes me sick just thinking about it. Y is equal to x squared plus 2. Somebody complained today, said I talk too much about alcohol. All right, now what we're going to do? We're going to what?
Flip.
Switch it. And that's going to be x is equal to y squared plus 2. Now solve for y. X minus 2 is equal to y squared. And what?
Square root.
So y inverse is equal to the square root of x minus 2. Now graph those two. And this is where you're going to actually see more of the symmetries. You can't see it with a straight line as much. So I'm going to bring up my handy dandy calculator. And I'm just going to leave that there. And I'm going to graph y is equal to x squared plus 2. And we all know what x squared plus 2 is. What is it? X squared plus, what is that?
Parabola.
It's a parabola with vertical shift of what? 2 up. Good. And then this is going to be a square root function, which means it's going to be a swoosh to the right because it's a square root function because and it's going to have a horizontal shift of 2 to the what?
Right.
Right. Thank you.
Right the first time.
Yeah. I just tried to ignore you.
You did.
All right. Square root. Try to find the square root button. Where's the square root button? I can't see on this screen. Somebody's got to tell me where it is. I can't see it. Can y'all? Because the
I don't know if it's in blue.
I'm just going to raise it to the 1/2 power.
X squared.
It's right above x to the third.
Okay, I see it. So, can y'all see that blue radical right there? I can't hardly see it. All right, so it's not me. I'm not blind. It's just I can't see that. Okay. The blue just don't come up very good. Okay, is that a parenthesis? I better put parentheses here. And delete
X minus 2.
x minus 2. And then delete. There we go. And graph. Now, before you say, well, I don't. Uh-oh. Got an error. We got an error.
Error.
Racist. I want it.
Yeah.
Okay, wait a minute. I hate this calculator. I'm sorry. I hate it. I really do hate this calculator. There.
Now.
Now that should work.
Iron.
Understand what's wrong with it?
Why does it keep, I just probably,
It's supposed to have that whole thing. It keeps putting these.
just the basic, sorry.
Oh, it's because you didn't write it under there. It
I
was
thought I
already
did.
there, but it was outside of it.
Square root, second, square root, x. Okay, I guess me using parentheses is not correct. X minus 2. There we go. Graph. Now, why is it only going to show half of the second function?
Well,
That's
because
not
it's the square
rhetorical.
root
I
of
want y'all
X.
to actually use your brains and tell me why it's only showing half the function.
Because it's the square root of X.
Because it's the square root of x, and you can't take the square root of what? A negative. Good job. So, if you look at these two, if it was to be, would these two be the same? Symmetrical? Yes, they would be symmetrical, but this one is flipped on its side because the inverse is usually on its side compared to the original. It's usually on its side. Okay? So you have to use your imagination right here because you can't take the square root. Now, if we was to give this guy a vertical shift of, +6 or something, then we would have a parabola up here a hyperbola that would look like a parabola. Okay? And so we could actually change this to x squared plus 6. We would have to do y is equal to x squared, let's see, I'm thinking, y'all, that would be square root of x minus 2 plus 6 is equal to y inverse. Y inverse, so that means I need to switch. So x is equal to the square root of y minus 2 plus 6. So that's going to be x plus 6. And let's see, that's square root of y minus 2. So that's quantity squared. Quantity squared. So y is equal to x plus 6. Quantity squared plus 2. So graph those two. Somebody graph this one and graph this one right here. Graph those two. I just want you to see what will happen when you see what the symmetry is with the inverse. So I'm going to go in and graph as soon as I get my cursor back. All right, the first one is, let me get rid of this, x plus 6, quantity squared. So x squared, I'm sorry, it's supposed to be x squared. No, x plus 6, quantity squared. So I'm going to clear this, and I'm going to do parentheses, x plus 6, quantity squared, plus what? Plus 2. And then my inverse function, or both of them are inverse to each other, is going to be the square root of x minus 2. And then I'm going to cut off the square root symbol. How do I cut it off? I guess I'll put a parenthesis there. No. Oh, I know. Delete. And then arrow. There we go. X plus 2. X minus 2 plus what? 6? All right, graph. There we go. All right, it's still not going to do it because it's still not going to, because you get a negative no matter what you put in there. I'm not thinking. But I'm trying to show you that you still get, and let's see if I can move this, the same function. Look there. Now, are these two symmetrical? Yes. But you can't take but half on the square root Because if you plug in a -6, you're going to get a -8, all right? And it's going to be, so that's why you have, but I want you to see that they are symmetrical. The y function is going up, but what is the other one doing? It's going to the right. And that's going to happen, that's what's going to happen with your inverse functions. Okay? That's what, I just want you to see it. Now, are all these pretty much going to be on the calculator? Yes, as far as the graph goes, but you need to be able to do it on the test algebraically, and I just gave you 2 test questions. Okay, we just did 2 test questions, so it's not that big a deal. It ain't rocket science. You just write y instead of f of x, then you switch the 2 variables, and then you solve for y. It's nothing but algebra. Everybody with me?
Yes, sir.
Okay, let me go back to the current slide. All right, here we go. Is this another one? Okay, this is a cubic function. Do that one. Now, you know this is the cubic function with a horizontal shift of what?
2.
To the what?
Right.
To the right. So, go to your parent graphs. You know this function. I want everybody to draw this function right quick up in the top right-hand corner. You know this function looks like this, but it's got a horizontal shift of 2 to the what? 1, 2. So, that's what it looks like. Now, with the cubic function, it's going to be kind of like put on its side. All right, it's going to be laying down. Instead of going up and down, it's going to be laying down and going left to right. So, let's do it. Y is equal to x minus 2, quantity cubed. I need to do that in black. I'm sorry. What can I use besides black? Non-white? Oops, I need to make that dashed. Why don't I just erase the whole thing? I suck. Be quiet. Alright, so here is our parent graph, and we know it's moved to the right 2 places. So our inverse function will probably look like this. I'm going to do it in red. I'm going to just, that's what I think it'll probably look like. As soon as I get rid of that stupid, I'm going to get trained on this one day. Y is equal to, they may give us posters, put a set of posters on the wall to show us how to use it. Y is equal to x minus 2, quantity cubed. How do I undo a cube? Well, I'm sorry, got to switch. X is equal to y minus 2 cubed. Now, how do I undo a cube?
The square root of x to the 3rd.
Not square root of what?
Not the cube root.
Cube root. So I'm going to take the cube root of both sides. I'll do that in blue because I got to undo a cube. So I'm going to take the cube root of both sides. So now, things I do for y'all, changing colors, and y'all are so spoiled.
We're so grateful.
I should use posters is what I should use. Because I'm not innovative. Y minus 2 is equal to the cube root of x. So the cube root of x is plus 2 is equal to what? Y inverse. Now you can rewrite that. If you want to punch that into the calculator, you can do x to the what? 1/3. X to the 1/3 power plus 2 is equal to y inverse. These are both the same thing. I punch those in the calculator, and I want you to see what the difference is. So I'm going to take my handy-dandy calculator. And y is equal to, I'll turn it on. Y is equal to, the first one is x minus 2 to the 3rd power. So I'm just going to change this to a minus 2 and change this to the third power and delete, delete. Now I'm going to go down here and I'm going to make this the cube root. So I'm just going to clear all this. And I'm going to say the cube root. Well, I'm not going to use the cube root because I don't even know if this thing has it. So I'm going to put parentheses, x, close parentheses, to the 1/3 power, parentheses, 1 divided by 3. And then go down. And then, what, plus 2?
Plus 2.
Yes, sir.
Okay, and I'm going to erase this because I can't see it. There we go. And hit what? Graph.
Here.
There's that function. And then there's that function. Okay, I had the vertex wrong. Okay, and you see that the first function is going up, down, up. And then the second function, yeah, I had it about right over here. And then the second function is what? Going left to what? Right. Okay.
Interesting.
That's your third test question. Now you should be able to do two things. You should be able to do it algebraically, and you should be able to graph both of them. Okay?
Can you hear that, Hubert? The ringing?
I'm sorry, what?
That was weird. Our speaker was just ringing, like, really loudly. That was odd. It just stopped. I'm not the only
It's the
one.
ones that don't talk about it.
Genetic psychosis.
We know she did Saturday.
Yeah, we know. She was on the front. She was one of those crazy people that drink too much. It's leftover. You know, you can still be drunk after you partake.
A little bit more.
Yeah, exactly.
Oh my
I
God.
think you may have a problem. I need to call counseling for this. There we go. And y inverse is equal to cube root of x plus 2. So make sure you can do those kinds of questions, and they're showing you graphically. And now they're going to do the rest of them in graph. They're going to show the graph, and then you see that it is it's a mirror image, but it's usually the down to up is usually transferred left to right. Okay. See, the first function is going.
Starting as the inverse is a negative.
See this one. What is the original one doing? Let me put this in red. This one's going what? Going down, up. What is this one doing?
Left, right.
Left to right. You see what I'm saying?
Starting from the negative side.
It's usually, yeah. It's usually going to be the opposite. Okay? But that's why you got the calculator, so you can see it better. Okay, they want you to find this one. This is another good test question. We're going to do it because it's a good test question. If it was a stupid test question or a stupid question, I wouldn't cover it. All right, here we go. So y is equal to the square root of x plus 5. All right? So x is equal to the square root of y plus what? 5. How do you undo a square root? No, square.
You square it.
Red or blue. I'm going to square this, and that takes out the radical. And x squared is equal to y plus 5. So x squared minus 5 is equal to what? Y inverse. Now graph those two. And I'm not going to graph them on the calculator because my parent graphs, I know my parent graphs. What does that square root function have? It has a horizontal shift of what?
Negative 5.
Well, 5 to the what?
Negative 1.
5 to the what? The right or left?
Oh,
You said it.
Left.
You said negative. Left. All right. So 1, 2, 3, 4, 5. And what does the function look like for the square root function? It's the what? The swoosh, like that. So this one's going like left to right, but it's also going in a bottom up position. What is this one? This is a parabola with a vertical shift of what? 5 what? 5 down, Hubert. Have y'all forgotten everything I've taught y'all? Okay. Well, you shouldn't, because we've gone over it so much. X squared minus 5. This is a vertical shift of 5 what? Down. And since it is a parabola, it has both sides, but both sides are going to look like what? Like this right here. So there's your function. What if I wanted to find where these two intersect? What would I do? Set them equal to what?
0.
Each other. 0 gives you the x-intercepts. If I set them equal to each other, I would be able to find what? Where they intersect. Write that down for future classes, especially calculus. If you ever want to find where two lines intersect each other, you set them equal to each other. Let's do that.
All right.
Just to test your algebra. Just to see if you really suck or not.
What is algebra?
Square root of x plus 5 is equal to x squared what? Okay? What do we do first? By squaring both sides. I'm impressed. Dang on, that don't look like magenta. I punch magenta and I come up with purple. It's the Russians.
It's like blue.
It's not blue, you're colorblind. See, that's what I hit. Now, does that magenta look like that?
No.
No.
It's like purple. There's blue. And then the blue looks like aqua.
They all look like blue.
I'm ignoring you right now. X plus 5 is equal to shortcut number what? Shortcut number 2, Hubert. That's right. So that's going to be x to the 4th minus 10x squared. X to the 4th minus 10x squared plus what? 25. And now you just bring over the x's. And that's going to be 0 is equal to x to the 4th minus 10x squared minus x. What is 25 minus 5?
20.
Dang on 20. And you would solve that. And it looks like you could factor out do it by grouping. I don't think or you could divide. But anyway, you'll get into that with calculus. But that's all algebra right there. This is nothing but 100% pre-algebra to algebra 2. But people suck at calculus not because of algebra. They just suck, because of calculus. Wrong. You suck at calculus because you suck at algebra. 90% of calculus is algebra. So make sure you keep this notebook because your first unit test in calculus is going to be what's in this notebook. Okay?
Okay.
Or you could just quit and go into a liberal arts major and not get.
Yeah.
Okay? That's what I tell my daughter all the time. She's going into history. And I told her, I said,
Good luck being a teacher.
don't feel bad if you don't get a job. Just remember this. The more math and science you got, the better off you are. And you can get mad at me for saying that. Get a prayer closet pillow and a puppy. I don't care, but that's true. Okay, next one. Oh, we did that one. We already, I think we did. Oh, this is one-to-one function. Okay. This one. Okay, this one we can get. Okay, we're going to do this one. And the reason we're going to do this one is because this is 5.3 and what we're doing right now. How do you solve that? Well, first of all, you got to change it into y is equal to what? Y is equal. This is a complex rational is what it is. It's a fraction.
It's hard.
Yeah, might as well quit. Don't even try. Y is equal to 2x over x minus 1. Now, what have I told you always with fractions? Should you
Give up.
besides giving up, should you deal with it or should you get rid of it?
Get rid of it.
Get rid of it. How do you get rid of a fraction? You multiply both sides by its what? Huh?
Denominator.
Not by its inverse, by its common denominator or denominator. You don't want to do the inverse yet because that'd be too much. But you can do that. You're not wrong. But we don't want to do all of that right now. We want to take the blue, and I'm going to multiply both sides by x minus 1 over 1. That's the denominator. X minus 1. Oops, I'm sorry. I forgot to interchange. I'm sorry. I'm getting the cart before the horse, for those of you that know what that means. Hold on a second. Oops.
Get in the car before the horse.
Well, your parents should have told you what that means. If they didn't, they're not very good parents. I'm kidding. It's a joke, okay?
What did you say about
Oh, yeah, exactly. Cart before the horse.
I'm gonna go to the department head and complain.
There you go. Knock yourself out.
He called my mama.
Yeah, exactly. That's exactly what somebody would say. All right, so here we go. Change x is equal to 2y over y minus 1. Now what? Multiply both sides. This is where you use 5.3. The denominator is what? Y what? Y minus 1, Hubert.
1 minus 1.
So multiply both sides by y minus 1. And that's going to give you, y's go out. I don't think this is, get my black marker. And that's x times y minus 1 is equal to 2y. Now I've got a problem that I can solve for y now, but I need to get the y back on the other side. Do they want you to do this? Let me see what they do, because
I don't think so.
yeah.
I think we should just move on.
Right now I can't move on. It won't let me. It's frozen. There we go. Okay, x is equal. Okay, they do. I wanted to make sure. Yep. That's what I just did. Okay. There we go. Distribute the x because you can't do anything, so you have to distribute the x. I wanted to make sure they wanted us to distribute. So distribute here. That gives you xy minus x is equal to 2y. Now we got to get the y's on what? Both sides. How do you get rid of a negative xy or a positive xy? You subtract it. That's minus xy over here. And what happens? You get negative x
Negative 2x.
is equal to y times 2 minus what? X. What did I do there?
Cancel.
No, I didn't cancel out nothing. Why? What did I do?
The opposite of distributing.
Real simple. Pre-algebra. What did I do?
You pulled out the common factor?
Common term.
The common term.
Common
Okay.
term. What's common with 2y and xy? So
Y.
factor it out. That's your pre-algebra. So how do I solve for y? Divide by 2 minus what? So y inverse is equal to negative x over 2 minus x. Now graph those two.
It's the Russian.
That'll be the department head.
Yeah, somebody called my mama a horse. That's why I'm glad I record all my classes. Because I did not call anybody's mama a horse. I said, you get the cart before the horse. And if you don't know that, then your parents didn't do very well. And I said, I was kidding. He called my mama a horse.
You edited the video.
Yeah. Okay, if I send you to the voicemail, that means I'm in class. I'm going to turn it on vibrate because he's going to call again.
Sorry.
All right, so pull up my handy dandy calculator. So this is the fourth good question for a test. F of x, oh, I'm sorry, y is equal, oops, sorry,
Oh no.
y is
Oh gosh.
equal. And I'm gonna put parentheses, 2x, told you, 2x, and he's a retired teacher. 2x, parentheses, divided by x minus 1, parentheses, x minus 1, close parentheses. And then the next one, I'm going to put parentheses, negative x, close parentheses, divided by parentheses, 2 minus x. Now you can actually, what is 2 minus x? That's negative x plus 2. So you've got a horizontal shift, and you also got, it's a half a volcano. So, because of your parent graphs, close parentheses, and graph. There's one, and then the other one is going to go up. Oh well, there it goes. There it is. So let's change it. Let's go back, and I'm going to change the second one to a dashed line. There we go. Now, should any math teacher expect for you to graph this by hand? No. Wait a minute, why didn't it it didn't dash the second one, why not? Okay, second one is that one. I don't know why it didn't break it up, but it should. Let me do this. Let me change the second one to a dark line. There's the first one. There's the second one. Okay? And that's how that works. Now, how do you know what the vertical asymptote is? Set the denominator equal to what?
0.
0. X minus 1 is equal to 0. The vertical asymptote is equal to 1. Okay? Now, this one is a prime example of a teacher wanting you to do it by hand and graph it on the calculator because it'll take you forever to graph it by hand. But I hate the calculator. I don't tell y'all to use the calculator at all, do I? You don't use the calculator to do what your brain can do. All right. Next question. And they go through and do it. Okay. I'm not going to do that. That's using our examples, blah, blah, blah. I'm not going to worry about that. Okay. Now go to what we really need to get to, and that is handy-dandy logarithms. Now, make sure you write good notes on this, please, because this is stuff if I'm going to test you on the 3rd of December, it's going to be on this chapter. All right? 80% of your test is going to come from this chapter, as well as the online class. It's going to come from this chapter. All right. So, and it's not that difficult if you listen and take good notes. Exponential functions. Okay. I told you to make sure you can graph with a calculator. Make sure you can graph 2 to the x. Make sure you can graph it on your calculator. Y is equal to 2 to the x. That's all I'm going to do there. Okay? That's what it looks like. And that's one. Make sure you can graph y is equal to 1/2 to the x power. It's going to look about like that. Remember, there's things I let you do on the calculator. These are all calculators. I'm going to get to the logarithms, if we can get to them, hopefully. Okay, eventually we're fixing to get to them right now, because you can write this as a logarithm, but they're not going to show you until you get to the definition of a logarithm. This is a good question to write down. Write down this question. The reason is because there is a law of exponents that people forget, and it's this question right here. And you will use this in the logarithmic section. 25 to the x power is equal to 125. Everybody understand that? Now, what if I wanted to make the same base? Could I do it? Yes, because 25 and 125 are multiples of each other, right? 25 is a multiple of 125. So I can rewrite this as 25x is equal, or 5 to the 2nd power is equal to 5 to the 3rd power. There we go. Now, make sure you understand from here to here. All right, I want to make sure everybody understands this. So if you don't understand it, sorry, backspace. There. No, I don't want that yet. There. I want everybody to understand this step right here. So if you don't understand this step, tell me right now. What is 25? 25 is 5 to the 2nd power. What is 125? 5 to the what? 3rd power. Does anybody not understand this? Now, what does the power rule of exponents say? If I have a power raised to a power, what can I do with these two powers right here? What does the power rule say of exponents?
Multiply them times each other.
I can multiply them by each other. So that's going to be a to the n times m. So what can I do with these two right here?
Multiply them.
So that would be 5 to the 2x, right? And that's what they do. Now, this is very important for you to remember, because a lot of students forget this next step. The next step that we're fixing to do, they forget. Can anybody tell me what the next step is? Don't be shy, because I need to know if you remembered it or not. Okay? Take your highlighter and highlight the 5s. What do they represent? The 5s represent the same what? Base. Does everybody understand that? Yes or no?
Yes.
Okay,
Yeah.
I got 1 yes. Thank you. 2 yeses.
Yes, sir.
All right. So if I have the same base, then I can set the exponents what to each other?
Equal.
Equal to each other. Write that down. If I have the same base, and that is the rule that people forget with the law of exponents. If you have the same base, you can set the exponents equal to each other. But the bases have to be the what? They have to be the same. That's why I highlighted them. So you need to highlight those two 5s and then circle. And I can say 2x is equal to what? X is equal to 3 halves. Therefore, 25 to the 3 halves power is equal to 125. And that's true because this is exponent over what? This is exponent over index. So in other words, that is the second root of 25 to the 3rd power is what that is equal to 125. Now what is the square root of 25?
5.
And what's 5 to the 3rd power?
125.
So it's right.
Woohoo!
So that's how you need to remember that. And the reason you need to remember this right here, from here to here, that's the star. That's what you need to remember. When the bases are the same, you can set the exponents equal to each other. And I guarantee you somebody in here said, oh yeah, I remember that. But it's from a long time ago, maybe pre-algebra or algebra 1. Okay? Now do you remember it?
Yes, sir.
Thanks, 1 or 2 people. All right, so remember that because you're going to use that in logarithms. All right, let's see. Actually, this is a booger, but you can do it. First of all, can you write 81 in terms of 3, and can you write 1/3 in terms of 3? Yes. You can change it to -3. Hold on. There we go. Now finish that one. You should be able to finish it. You done called 3 times. Yeah, just come on back whenever. That's fine.
That is fine.
I'm sorry. I
I
can't
didn't
hear
do
you.
it.
All right, so what do we have? What happens when you do that power rule now? What you going to get? Somebody tell me what you get. 3 to the what?
The negative x power.
Is equal to 3 to the what?
4.
4. And now I'll take my handy dandy highlighter. And what are these? The same what?
Bases.
So the exponents are what? The exponents are what to each other? Thank you. And what is x?
-4.
So therefore, 1/3 to the -4th power is equal to 81. What can I use? The law of exponents, there's a law that says if I flip what's on the inside of the what? The parentheses, what will happen to the exponent outside?
The sign
It
will
becomes
change.
what? Not negative, but what?
Positive.
Positive. It switches the sign. So 3 over 1 is now raised to the 4th power, which is 81. That's 3 to the 4th power is equal to 81. And 3 to the 4th power is what? So it checks. So x is equal to -4. They should be going into the logarithmic definition within the next couple of slides. All right, try that one. What's the first thing I would do on this problem? Change that decimal into a what?
Fraction.
Fraction. Yes. So I'll do that for you. It's 3/2. So 3/2 to the what? X plus 1 is equal to 27 over 8 to the what? X power. All right, do it. Now, you can't change 3/2 into anything, so that reverts you to what? 27/8, Hubert. That's right, class. So what can I change that 27/8 into in relation to the 3/2? 3 to the first, 3 to the second, 3 to the third. So what can I change it? So this would be 3/2 to the x plus 1 is equal to, that's going to be 3 to the 3rd power over 2 to the what? 3rd power to the x power, which is 3/2 x plus 1 equals 3/2 to the 3rd power to the x power. I want everybody to make sure they understood. Let me erase that confunction right here. I don't know what did that. 3 to the 3rd power. There. So the power rule says that I can take these two and do what?
Multiply them.
So that's going to be 3/2 to the x plus 1 is equal to 3/2 to the what? And the bases are what? Bases are the same, therefore x plus 1 is equal to what? 3x. And what's x minus 3x?
2x.
And -2x is equal to -1. X is equal to what?
1/2.
Let me check the time before some of y'all self-combust. We still have time. I should be hurrying because I got somebody that's about to blow my phone up. Hopefully it's somebody wanting to buy some land. And let's check and see if we know what we're doing. Oh, look at there, 1/2. It's a miracle. That's a good test question. Now again, we're only talking about 20%. So far I've only shown you 20% questions. Those first 3 that we did, graphing and, inverse, and then so you're talking about 1 or 2 questions. I'm not worried about graphing. You can graph that on your calculator. Worried about that. That's the same thing. I'm not worried about that. That's the same thing. That's just inequalities. I'm not worried about that. I'm worried more about, that's plugging and chugging. I'm not worried about that. You should be able to plug and chug on that. They're just plugging and chugging. R is equal to that, N is equal, and use your calculator. Guess we're never going to get to the logarithm. I guess logarithm is going to be the next section. Yep. Let me go ahead and pull it up. Trying to find it. Just give me a second. Here it is. What section was that? 6, 6.2 or 6.1? 6.1. Oh my God, really? They spend too much time on this. It's the same stuff we just did. All right, I'm sorry. I thought I pulled up, what was that, 6.2? It must be 6.3. I suck. 6.3.
First step is admitting you have a problem.
Yes, exactly. Yes, there we go. Definition of a logarithm right there. Okay, there's about 5 things that I'm going to teach you in logarithms. This one is the most important. Okay, so let's go ahead and do slideshow, and I want you to write it down right there. The part that I want you to write down that's very, very, very important is right here. Y is equal to log base A of x. You can rewrite that either way as a to the y is equal to x. That's the way I write it. That's why I changed it. Okay? I can either write an exponent as a logarithm, or I can write a logarithm as a what? As an exponent. A logarithm is a glorified exponent. You can also say a logarithm is best in the first quadrant. Yes, because you can't take the log of a what? A negative number. So if I'm in the first quadrant all the time, what do you think logarithms pertain to in real life? What's in the first quadrant, or hopefully in the first quadrant? Business, economics, huh?
What's that distance?
Business and economics. Because what do you not want in business? Negative numbers. All right. What do you not want in marketing? Negative numbers. What do you not want in economics? Negative numbers. So most of your theories and most of your things in economics and business are in the first quadrant. That's why you have a lot of logarithms in the first quadrant. I mean in business. So this is called the definition of a logarithm. And on a scale from 1 to 10, on the 80% questions that you're going to get on this last test, this is about a 15. So if there's anything that you need to memorize in this logarithmic section, it's that logarithm I've got in red right there. Now what does that mean? Well, you're going to see on the next slide. And I know some of y'all are going to blow up. I've got 7 minutes. I just want to cover just some of these that I want you to make an index card or a printout. You can look this up on Google. Properties of logarithms. There's about 6 of them. This is the first one. Okay, there is the logarithm. Here's the exponential form. If I have 2 to the 3rd power is equal to 8, I can rewrite that as log base 2 of 8 is equal to 3. And if I have logarithm base 2 of 8 is equal to 3, I can rewrite that as that. So you need to make that relation. However you need to make it. But the definition of a logarithm means that I can take an exponent and I can change it into a logarithm, or I can take a logarithm and change it into a what? An exponent. Now, why do you need to do that? Well, when we get to the solving logarithmic equations, sometimes it's going to be easier to change a logarithm into a what? An exponent to solve the equation. Okay, a lot of people say, well, Hubert, how did they do that? Log 1/2 16 equals -4. I'm sorry. That's a different example. I'm sorry. This example right here, basically, at base, the A is 1/2, A to the Y, 1/2, Y is equal to 4, -4, A to the Y is equal to X. X is equal to this right here. Let's see, A to the Y is equal to X. So let's see, log base A is 5, A of X is 5, is equal to 1. So that's what you should get over here. And you should be able to do, okay, this is log base A of X is equal to Y, and I know it's A to the Y is equal to X, okay? So that's going to be A is what? 3/4 to the what power? What? 0 is equal to 1. What's any number raised to the 0 power? It's equal to 1.
1.
Any number raised to the 0, you think of multiplication. Okay? Anything raised to the 0 power is equal to 1. All right? Okay? So that's how you use the definition of a logarithm. You're going to come back and use the definition of a logarithm in like 6.4 or 5 when we're doing logarithmic equations. But that's one thing right there. If you don't remember it, if you don't write it on a card and highlight it, then you're going to flunk this test. I'm going to skip this right quick because I want to show you the next. I want to get you all to write down all the properties. Okay? Well, evidently, I'll talk about logarithm and there we go. All right, write that one down. Oh, 3, there's 3 of them. Log of 1, no matter what it is equal to what? 0. I need you to take your highlighter out and highlight these 2 right here. If these 2 are the same, your answer is what? Your exponent. If the base is equal to the x, if those 2 are the same, then your answer is the exponent. And these are just basic laws. And then if you have if these 2 are equal to each other, if this right here is equal to the base of the log in the exponent, then the answer is k. But k has to be positive. Now those are 3 basics, but that's not important as the next one. The next screen right now, and then we'll quit after this next screen. And I've got 3 minutes, so some of y'all can just chill. That k is greater than 0 means k has got to be positive. If k is equal to -2, then it won't work. It's you put does not exist or unsolvable or no solution or whatever. Make sure you highlight those or circle what's in common in number 2 and number 3. You cannot take the log of a negative number. You need to remember that. What does it say right there? For a is greater than what? 0. Okay? So you cannot take the log of a negative number. All right, next. There is the next most important right there. Number 1 is the definition of a logarithm. The other three that you have to remember are these three right here. And there's one more, it's change-based formula, which I'm not going to get to today. But those, so when we reconvene Wednesday, we're going to do problems with the product rule, the quotient rule, the power rule, and the definition of the logarithm. We're going to do nothing but problems. That's all we're going to do. So I would challenge you tonight or tomorrow when you go home, make sure you read up on what section is this, 6.4? 6.4 in the book. Make sure you read up on it a little bit. And don't do any problems, just read up on it. And those are the three. And change base is real easy. Change base is the easiest of the four. Okay? And once you do 2 or 3 problems with the change base formula, you won't even have to write it down. You know how to do it, punch it in a calculator, and you're good. The least important is the change base formula because you don't have to memorize it. All right, when y'all finish writing those down, y'all can skedaddle. Make sure you work on 6.1 through 6.4 questions. Read 6.4 and work on a couple of 6.1, 6.3 questions. Do not worry. I know it seems kind of crunched, but when we go over the last day of class, when I go over the test, you'll see what's going to be on the test. It's not going to be, don't start spazzing, okay? All right, y'all get out of here. Have a good day.
Hubert, I have
yes, ma'am.
some stuff. The 2 tests that I took, could you fix some questions for me?
Yes.
I meant to ask you last time, but then I was like, well, I just need to take the other test.
Well, since I'm so far over today, let's do it Wednesday, okay? And remind me at the beginning of class, okay?
Okay.
Because they're going to knock down the door in the next class, and up there in Pendleton, them people at Pendleton, they don't play. They'll knock down the freaking door and they'll leave. So I'm gonna go ahead and cut it
I know,
off.
we have to run for our lives.
Exactly. So remind me at the beginning of the class, okay? And the rest of
Okay.
y'all have a good day. See y'all Wednesday.
Bye.
Bye.